this is the part, this is the reason I saved this for last. This is the part with the inverses that you could, my best students, could get a little confused at times. I would suggest first that you jot down right quickly the restriction for inverse sign, that we had to have a restriction to make it 1-to-1. Does anyone recall where must I look for the answer?
Between negative pi over 2.
I think it's bracket, negative pi over 2 up to
Pi over 2.
pi over 2. I think that was a restriction for inverse sign. Now, Ignacio, it says now, translated, says this. I know my restriction. It says now find the angle, that's called that restriction, and it does this. Here's the translation. It says sine theta, that you're looking for, will give you this. And as soon as you find it, that's the answer. Now, thank goodness, I think this one you'll recognize from the unit circle. Does anyone recall where on the unit circle have you seen sine equal to a negative? And first, can you tell me in which quadrants is sine negative to begin with?
4.
Not 1, 3, and what? 4. And you know I can't use both, because I've got to use 1-to-1 here. Quadrant 3, please help me out. The angle in quadrant 3, I think, help me. What's that? 5 pi over 4. You gotta know this. Quadrant 4, help me out. What's it? 7 pi over 4. Is that true? I can't accept both those. I'm talking about 1-to-1. So is it 5 pi over 4? Or is it 7 pi over 4? And also, besides being 1-to-1, just one answer, it's got to fit between negative 90 and positive 90. Guys, this may be better to look at it like this. This is 225 degrees. 5 pi over 4, 225. Does 225 fall between a negative 90 and a positive 90? That's out. This one I think is even worse. I think this is 315 degrees. Does 315 fall between a negative 90, which it should, and a positive 90 by restriction? No. Professor, there's no answer. There's an answer.
Negative pi.
Yeah, you got to write this what? Negative pi over 4, and make it fit between those two, negative 45 degrees. That will work. And therefore, that's the answer after all that thought. Shane, tell me what the next one is asking.
Secant
Secant, okay.
of,
Inverse secant?
nope, regular secant,
Secant up, okay.
inverse tangent of negative 2 over 3.
I'm not messing around with this.
No, you're not.
Now this would scare me as a student. I've got inverse tangent going on with a secant. First, we translate for you. Inverse tan has a restriction. The angle's got to fall between, and guys, do not let me write this down wrong here. Does it fall between those two?
Yes.
Right? That's a restriction. This means, translated, there's an angle out there, theta, that when you take its tan, you're supposed to get this. Now watch carefully on this. And that particular angle is supposed to fall between these two. Now what angle is it? I've never seen tan equal to a negative 2/3 on the unit circle. But we still get the answer. It's just so happens we're not on the unit circle like we were on this one up here. I don't think you guys have ever seen a negative 2/3, have you? No. Now can someone, and then we're supposed to take secant of that angle afterwards. I have no idea what the angle is. Because they're asking me to find secant of it. Does anyone have an idea how to approach this? Do it again.
Figure out the quadrant.
I can figure out which quadrant we're in, and let me do. This tan is negative. Guys, in which quadrants is tan negative?
Would be 2 and 2.
Y for X. On the unit circle, where is tan negative? Quadrant 2 and quadrant 4. Billy, I agree 100%. Now I'm going to ask Mr. Parker shortly to tell me what that angle is. Because it's going to be a strange one, but it's got to be either in quadrant 2 or quadrant 4. Is that true, guys? So I at least know the location. But yet, I got to find the secant of it, and I don't know what the angle is. If I knew the angle was 30 degrees, I could find secant 30. If I knew if I knew the angle was 45 degrees, I could find it. But I don't know. Something else. Look at it closely, guys. This is the one that, this is a little tricky. You gotta find secant of that angle, and the strange thing is you have no idea what the size of the angle is, but Billy says it's gotta be either in quadrant 2 or quadrant 4, Professor, but I have no idea what size it is. And I don't have any idea what size it is. Mr. Park's gonna tell me here shortly. Yes, Alex.
Let's do 1 plus cotangent squared equals.
Whoa. You're telling me you're thinking about this. Are you kidding? Is that a true statement? What's tangent equal to? A negative 2/3. He says go through that identity and just put it in, Professor. Put this in. Without me knowing what size angle it is. Makes sense that he could use an identity like that? And if I clean this up, guys, this is 1 plus, help me out, 4 over 9, is it? Mr. Park, get ready, because you're going to check a few things for me. Guys, help me out. What is it, 13 over 9? I'm in a strange answer here. Now, do a square root. I got to be careful. If I do a square root, guys, at this point, it's plus minus radical 13 over what? 3. Alex, good suggestion. But you know I can accept only one answer. But he really got to start well on this. Still, I don't know the size of the angle. We still found the answer. That I did it. Well, Ignacio, we're supposed to be either in 2 or 4.
We're in 4 because we have the restriction and we have 5 or 2 to 7.
And it's supposed to be caught between what? Negative 90 and a positive 90. And by the way, guys, please tell me. If by restriction, negative pi over 2 is here, positive pi over 2 is there. Is that true? Does that say if I'm caught between those two by inverse sign restriction, the answer's got to be either in 1 or a 4? Suppose could I accept the negative? Is secant negative in 1 or 4? What is secant itself in 1 or 4? 1 over x. Is it positive in both?
Yeah.
So that's the answer. I cannot accept the negative. So it's a positive radical 13 over 3 by the restriction here. Wow. You said, Professor, that's it? That's it. Now, if you had a calculator, now, I used to be, back in the day, I used to teach this with a calculator. I used the overhead and showed my class the calculator approach to it. We stopped that. Mr. Park, now be careful. Would you please, let me find it here first. Yeah, would you please find inverse tan, use your inverse tan key, negative 2/3, and tell me what that screen shows is the angle that we do not know yet. What is theta? Inverse tan, negative 2/3. And give it to me in degrees.
It's like negative 33.7.
33.7?
Yeah.
Hold on, that's degrees. I had no clue, me. That they were talking about a negative 33.7 degrees. By the way, guys, is that down in quadrant 4? You move backwards? Yep. So I know that agrees. Now, do me a favor. Find the secant of that negative 33.7.
It's like 1.20.
1.20?
Yeah.
Okay. So you're saying the final answer by calculator is that.
Mm-hmm.
We got this.
Mm.
Now find what square root 13 divided by 3, just merely that is close to. Mr. Park, don't mess me up. What's radical 13 divided by 3?
It's 1.20.
Same answer. Ignacio, did you realize that angle that we're talking about was 33.7 degrees? I didn't. Did we finally still get the answer though? Yes. With Alex's help. Shane, you're talking about a workout, guys, that was a workout problem. Now, is the next one on the handout the one with the little star next to it?
It is.
And we're not going there,
Okay, so
because let's jump down to the next part.
solve the given trigonometric equation.
Okay, hang on now, and what's that say to solve?
On, it's 0 to 2 pi.
0 to pi, okay?
It's 1 plus sine theta equals 2 cosine squared theta.
Beautiful. Guys, and she wants the answers caught between these two. My 4 o'clock session, we saw something like this. Now, before I do it with my class though, if across the street, that teacher, maybe in the algebra class over there, gave that for the middle school kids to do over there, they would freak out. What's wrong with that? What would be wrong with asking, let's say, a middle school kid to solve this? What would they think first? That's what it sort of looks like. This sort of looks like this. This is middle school, this is us. What's wrong with that middle school first problem? Did the teacher make a mistake? Did the teacher mean this? Should that have been an X? Could they have done it then? Would that be a quadratic? And they could maybe solve it by quadratic formula or factor. If that had been an X, no, the teacher had this. And all of a sudden they start looking at the teacher strangely and say, oh no, he or she's having a bad day. You can't solve it, what are you gonna do? That's the same thing down here. I can't solve this thing right now. It's like a middle school kid could not solve. Does someone have an idea that what we could do on our problems, the trig, that might benefit us, that kids across across the street, I don't think they could do it. Yeah.
Never mind, I was thinking 1 plus sine would be cosine,
Whoa, hang on again.
but it doesn't work.
1 plus sine is not equal to cosine.
Yeah.
Don't ever say that. This is true. Alex, you're getting close. That's an identity. That's always true. But never say sine plus cosine is equal to 1 or whatever there. Shane?
Could we subtract 1 from both sides to get it to be sine theta equals cosine 2 theta?
Oh, interesting. You mean subtract 1.
To move it over.
Hold on. I had not thought about that. Move the 1 over. I love this class. Move the 1 over. And she says, wait, Professor, that on the right-hand side was one of those formulas that you showed us right before the break. Which one was it?
Cosine 2 theta.
Wow. They put that in there. Shane, congratulations. All this is true. And you still got sine theta. Oh, look at this. Oh, my goodness. I'm so glad. Shane, I'm blessed. Now what? Because you got me started now. I hadn't even thought about this myself. I had another approach altogether in mind. I'm gonna do it this way though.
Can rewrite sine?
Now, rewrite cosine 2 theta. Now, I don't know the handout you have right now. Are those double angle formulas listed that we just went through?
Yes.
They are. Can someone tell me cosine double theta? Is that the one that has 3 versions?
That's not on.
Okay, flip it over. It's on the back.
Yes, it is.
Okay, flip it over and now look at cosine double theta since you got me into it.
Oh, do you want it in terms of sine?
Oh, yes, I do, because it's got a sign here. Which one has the sign?
So that would be,
2 sine.
yeah,
one, how much was it?
1 minus 2 sine square theta.
This?
Mhm.
Oh, Lord, I wish my colleagues could hear this. Okay, got sine theta. So true, guys? Now, she's being clever by using formulas. That's what it's all about. She has this now all in terms of sine. And Shane, I'm gonna move everything over to the left in the order I need it. Move that one over also. You guys, everything's been moved over. What do you think this is calling for now to try to complete it? Let U be what?
Sine.
Sine theta. If you do, you will write this as Shane. Congratulations. I think it's factors. Actually, not to be messing, I think the plus one, the minus one, step back and look at it. You guys agree? I think. You know how this works. You're going to end up with U equal to what? 1/2. And U is equal to what? -1, true? But U was representing what? Sine theta? So this says sine theta, what our class tonight, equals 1/2. Sine theta is equal to a -1. Go to the unit circle. We're back in the unit circle on this one. Where have you seen sine equal to a 1/2? The y coordinate.
5/6.
5/6. Now hold on. That's 30 degrees. May I use it because she gave me a restriction back here wherever I placed this problem. Where was the problem? Oh, here. It's got to fall between 0 and 360.
Yep.
Does my 30 degrees fall between 0 and 360? Has anyone seen another spot on the unit circle where the y coordinate sine is 1/2 besides 5 or 6? 5, 5 or 6. Now if you wish in degrees, that's 150. Am I still okay?
Yes.
I'll take it. Now those two are done. I think that's all you can do. Is that true, guys, for a 1/2? That one's done. Now, have you seen a spot on the unit circle where the y coordinate is -1? 3 pi over 2. Shane, you've helped your class out with all that beautiful reasoning. The original problem was, my goodness, where am I? Up here. That's the original. We just discovered, I'll use a different color here, the answers are 5 or 6 unit circle, 5, 5 or 6 unit circle, 3, 5 or 2. And you're finished. Shane, thank you, thank you, thank you. Now you say, Ramsey, what were you thinking about? You said you had a different approach. I was thinking about doing this. I love what she did. I was thinking about, here's the original problem for you guys, quickly change this into this. From this. Is that true, guys? Can I change it? Based on this?
Yes.
And if I do, is everything now in terms of sine? And I could have written this as 1 plus sine is equal to distributive property, this, on the right. Move things around, move everything to the left. Place it in order. Will Shane and I end up at the same spot?
Yep.
But I approach mine just a little differently. Yeah, but I love what you did because you made it connect to what we were doing right before the break. You used one of those double angle formulas. Now I see some heads shaking yes, 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 until you see that test next Wednesday. And I'll look back and I'll see heads going like this. Professor, I'll see you during summer. Might even see you during fall. Who knows? Is that beautiful, guys? Shane, what else is there on the next part?
We go into section 6.5.
Oh, so it had one equation to solve?
Mm-hmm.
Wow. Okay. Now, what's that section,
It gives us the sum and difference formulas.
which we did before the break?
And then,
What's it asking me to do?
well, after that, find the exact value of the given expressions.
Okay, so what the first one was?
Sine of 7 pi over 12.
Whoa. Okay. Oh, just that, 7 pi?
That's it.
Gotcha. Okay, guys, here goes. Have you ever seen a 7 pi over 12 in the unit circle? No, you never will. Now, if changing that to degrees would help you to see how to approach this, that's beautiful. Guys, if I use my conversion factor, can someone tell me in degrees, how much is that? Just out of curiosity. 7 pi over 12 in degrees, using conversion factor,
105.
105? If that would help. Well, 105, you've never seen a 105 in the unit circle, nor will you ever. But they're asking me to find the sine of 105. Alex says, Professor, I'm gonna use something we did before the break. And I think it's right there on the handout waiting for me. Is there a formula I can turn to? Alex, what you got in mind?
Sine of 4 pi over 12.
Hang on now. Sine of 4 pi over 12 plus 3 pi over 12, which definitely is 7 pi over 12. I love that. Even better, Alex, this is sine of reduced down pi over 3 plus what, pi over 4? Are you kidding? 105 degrees? I have no clue myself. Now let's finish this thing up. Now I need, Alexandra, I need the sine A plus B formula. And I think Shane's telling me all those formulas are listed on that handout. So here we go. Please see if I apply the right one. This is sine pi over 3, cosine pi over 4, plus cosine pi over 3, sine pi over 4. Is that correct? By using that A plus B formula. Now I put my replacements in. This is sine of 60 degrees or pi over 3. You guys, what is that? Radical 3 over 2? I think. Cosine of 45 degrees, pi over 4 is radical 2 over 2. No problem. Cosine of 60 is what, 1/2? And sine of pi over 4, radical 2 over 2. And we'll run out of time here, guys. Let's call this radical 6 plus radical 2 all over what? 4. There's the answer. Now you know, Ignacio, we all know now, if it comes up, the sine of 105 degrees, oh, Professor, no problem. What's this? Done. Shane, what else were they asking me to do here to sort of close this down?
We've got cosine, oh, this is a long one.
Okay, hang on. Okay, cosine.
Cosine 5 pi over 12.
Whoa, okay,
Cosine 7 pi over 12
got you.
minus sine 5 pi over 12
Hang on.
sine 7 pi over 12.
Sine 7 pi over 12. And I got 7 pi over 12, you have never witnessed that on the unit circle. And I said, no, go ahead and find the answer. Now something's got to click here.
It would be,
Now look at that. Is there a formula?
yes,
Which one is it?
cosine A plus B.
Thank you. That in the black matches up with that formula. Therefore, I can say all this mess is equal to cosine of, help me out, 5 pi over 12 plus 7 pi over 12. You guys agree? Which I think we lucked out here. This is cosine how much? 12 pi over 12, is that pi? Now that's cute if that's true. Is that pi? Now that does take me to the unit circle. What's the cosine at pi, the x coordinate? Ah, the answer is -1. Look at that mess, the black. That's where formulas are going to help you. Would it help if I allowed a formula sheet on the final?
Please.
No. Would it help if I had open notes on the final?
Oh, boy, what a.
That's not happening. Have I heard of it happening? I've heard of it happening. I've heard of it happening. Then they move into calculus and they'll have a clue. So all of a sudden the calc instructor says, nope, close book, close everything. But I was allowed to use my open notes. My teacher even gave me answers now and then. Professor Ramsey stopped by and said, you better change that before you turn that paper in. For Alexandra, I like you, the answer should be 0. Yeah, that's not gonna happen. Not gonna happen. The last day you may get a smile from me. That's it. The professor's papers. Jeez. Shane, let's finish this up. You're doing a good job. What's the next one?
Cosine of
Uh-oh.
inverse tangent. 4/3 minus inverse cosine 5/13.
Now, guys, I've been waiting all class for this. I have been known to give this as an extra credit. I'm gonna work this out. A student asked the professor, do we have any more extra credits? Maybe something, professor. Well, I'm thinking about 2 points. There might be 2 points coming up. I have been known to get this one. Something like this, to do it. Guys, look at it in this accelerated class. I don't know whether the other math2 instructors are approaching one like this, but I thought it'd be good. Because they want to see something to tie in with the way we've been, or what we've been doing tonight. And you'll be shocked. It all ties together.
Do the inverses first. And then-
Okay, now I could do that. Let me translate what those inverses mean. I could. And by the way, I have 2 of them here. This means there's an angle out there, let me call it angle A, rather than theta. That when you take its tan, you get this. That's what it means. By restrictions, this is inverse tan. Does anyone remember the restricted interval for inverse tan? So A must fall between those 2. Now, I have no clue myself what angle A is. I don't know whether it's 45 degrees, that's not 45, whether it's 32 degrees, it's 168 degrees, I have no clue. So that's what it means. Shane, class, I have another angle. This one, the fit in red. This means there's an angle out there whose cosine is this strange fraction. Now, does anyone recall where this angle should be? Because they all have different restrictions. If you're doing an inverse cosine.
Is this
0 to 2.
Don't scare me.
0 to 5?
I think 0 to pi. I think. Is that true, guys? Now, do I know, standing right here,
Yep.
what that angle is? I have no clue. I know where it is. Look, it's caught between 0 and 180. I have no clue what the angle is. And I'm gonna call that angle in the red. Now, what it comes down to, Alexandra, look at this. This now comes down to me doing this. You've got to come up with cosine of, look at this. This is so cute. A subtract B. That's what it comes down to. comes down to that, I must use what? A formula. Now, can someone remind me what cosine A minus B? I did cosine A plus B. What was the cosine A minus B formula?
Cosine A.
Cosine A,
B
cosine B,
minus
minus or plus?
plus sine.
Plus sine A, was it? Sine B? So to get the answer on this crazy problem, I've got to use this. Oh, guys, we don't have the answer yet. That would be an extra credit type. Mr. Park, we're going to think about something like this, a little tougher, to give him 2 points later on. Guys, I got to fill this in, and after I fill this in and do the math, that's the answer. I need cosine A. Then we'll call this A, I did. Let's call this B. I don't know why I put theta there. Let's call this B to make it look better. So I got an angle A and an angle B going on, which my formula says I should. I need a replacement for cosine A. Was cosine A mentioned here? No, tan A was. So I can't put a replacement in right now. I need a cosine B. Oh, they gave me cosine B? I can put that in. It's 5/13. That's true, guys? At least I got that. Sine A, I don't see it. Sine B, I don't see it. Now, can someone in this clever class tell me how to come up with the replacements that I need, that are missing right now? Okay, so I hang one up.
Well, we can find sine B.
Hang on now. You want me to find, because I need here, you want me to find sine B. And I did B in the red. Do the red then.
It's gonna be
How you gonna find it?
1 minus cosine B squared.
Look at this. Thank you so much. He's telling me, Professor, a basic trig identity says that. He says even better, I know what cosine is. He says then sine squared could be expressed as from this identity as 1 minus what, cosine squared?
Yes.
Oh, I love this class. Put cosine in, which they gave me, or we found, yeah, they gave it to me. So this is sine squared is equal to 1 subtract what? Was it 5/13? Don't let me mess up. Was it, guys? Let me put the work over here. Wow. Sine squared is equal to 1 subtract, I think it's 25 over 169. Yes or no? I got to do the math quickly. I think it's 144 over 169. Is that true?
Yeah.
Which I think is a perfect square root, because I got to do a square root. So right now, sine is equal to plus or minus, I don't know which it, I'll go back and look at this, 12 over what? 13. With his wonderful help, I will put either a plus or a minus 12/13 in there. Now what will determine whether it's a plus or a minus? Which angle should I be located in? Between 0 and what? Pi? Does that help? Oh boy. Because I know cosine is supposed to be positive. Right? Cosine's positive in 1 or 4.
Maybe quadrant
Woo.
1.
Between 0, cosine is caught between 0 and pi. Right? Between 0 and pi. Quadrant 1, quadrant 2. And we just discovered that cosine is positive. Oh boy, here it goes, guys. Quadrant 1? Therefore, it should be a positive also for sine, because sine is positive in quadrant 1. We're going to, Mr. Park, check this out for me. The big thing, though, about this is, I love it, I love it, I love it. This is 12/13. Is that true? Oh, I wish I would have saved this one for extra credit. Now, Alexander, can you help the class out with, I need a replacement for cosine A, and maybe a sine A, I don't care which one you find first, based on what you see up here, all I know about A in the green is this.
Would you use the identity?
Which one you want to use? I'm using green. Which one you want to use?
Is it 1 plus tan squared equals, is it secant?
Love it.
And then just use the H number?
Oh my goodness, you said it perfectly. Tam was give it to me. So in the green there, that's what, 4/3 being squared? Guys, this is lengthy, you're talking about lengthy. And this, Alexander, you're absolutely 100% correct. This is, I think, 25/9. Guys, I did my math real quickly, save a little time. I hope that's right. We put those two together, I think it's, Lord. And then I think it's 25/9. Do a square root. Now see at this point, with what she's given me, it's plus or minus 5/3 for secant. And then I think what she wants me to do though, because I need cosine. I have secant, what's the relationship between secant and cosine? They are reciprocal, so just flip this over, I'll do it up here guys in green, and cosine should be equal to plus or minus, I'm gonna get that for right now. Flip that over, was that 3/5? Reciprocal? Yes, no? Okay. Now, should be plus or minus. Well, I'll determine where I am.
First quadrant.
Yeah, I heard first quadrant again. If I'm in the first quadrant, that should be a positive 3/5. And with her help, Alexandra, thank you. The only thing missing to finish this up, this long, lengthy, thoughtful problem, if you're sitting there and you focus and you see at least parts of this come together for you, I commend you. This was a hard problem. I don't have this one yet. Does anyone have an idea how to find that one?
Sin squared theta plus cos squared theta equals 1.
Can we get now?
Sin squared theta plus cos squared theta equals 1.
Sine squared plus cosine squared is equal to 1. Hang on now. Sine squared A plus cosine squared A is equal to 1. Ignacio, they gave us, did we find? We found cosine A earlier to be what, 3/5? So put 3/5 in there, so this is sine squared A. 3/5 was discovered earlier for that one. And do the math. I think all this is going to be in quadrant 1. Sine squared equal to, that's 9/25. Move that over, do the math. Help me out, guys. 16/25. I did it quickly. Take a square root. Jeez. What is that, 4/5? Ignacio, I hope you're right. This is 4/5.
Yeah.
And the one in red there, which was given to me way back, which we accepted, was 5/13. Is that true? And there's a plus sign in between. Ooh. You guys making sense of all this? Now, final answer, be careful. I see what? 15/65, I think. Plus what? 48/65. Guys, you're talking about a strange answer, and this is the answer. Add them up, 15 plus 48, help me guys. 63 over 65. Go out, impress your friends. This is equivalent to 63/65. Mr. Park, now don't code, don't write complicated equations, because this guy's out here on a different level. Here goes. Help me out. find what angle is this right here. Inverse tan 4/3, tell us in degrees, hopefully, what that is. This inverse tan key 4/3.
It's like 36.86.
36.8. 86?
Yeah.
Okay, that's in degrees, no problem. Now do the same thing on this one, find inverse cosine 5/13. It's actually 5 there. The size of these angles, I have no clue what they are.
67.38.
57.38.
67.
Oh, 67.
Yeah.
0.38.
Yeah.
Now it says to subtract those two.
Hmm.
Okay, subtract those two, that's gonna be a negative answer. Negative what when you subtract those two numbers?
I think you'll be faster. Wait. 30 negative 30.52.
Negative 30.52.
52. Yeah.
Hang on. And then on the outside, they said take the cosine of that. On the cosine of that negative 30.52 and tell me, what does the calculator show that strange answer?
0.86.
0.86.
Yeah.
Mr. Park, I'm gonna be very disturbed. We got,
63,
where on earth is my answer?
In black.
Oh, right here. We got this.
Yeah.
See what 63 divided by 65 is.
Oh, it's different.
Whoa!
Maybe my typing was wrong or something.
I think cosine negative 30 is not.
What was it now?
Cosine negative 30.52 is should be.
It's not that?
Oh.
I don't have the calculator.
Wait, cosine 30 is like 1/2, right? No, it's
No.
not. No, it's root 3 over 2.
I'm already
I
talking.
So it should be like 0.7.
Yeah, it should be near 0.7.
And I sent this kid to math 11, and he's doing math 13.
So I think it read as radians or something.
You're supposed to have this in degrees. Susan. Susan. Could you find inverse tan 4/3 real quickly for me in degrees? Whoa, not 36.86?
Oh, I'm sorry.
Whoa. It's 63?
53.13,
50.
yes.
Okay, 53.13.
13.
Susan, find the inverse cosine 5/13 for me.
67.38.
You got that? Now, when you subtract these two, find that difference for me.
Negative 14.25.
Now, please, take the cosine of that result.
0.969.
0.96 something?
9, yes.
9. We got this. Now find out what 63 divided by 65 is.
0.69.
Same answer?
I'm sorry.
I've known this kid too long. Too long. What's it been now, 2 years?
Almost 2 years. Yeah.
Not 3?
Oh, it's been only 1 year. I met you last spring.
Yeah, but I had you for a winter session for my TA also, didn't I?
Yeah.
So you were with me during winter. Mark's been with me, now he's here with me again, he's gonna be with me in the summer, he's gonna be with me in the fall. Okay, guys, it checks. So we'll accept the answer as that strange 63 over 65. Look at this, guys, where was the original problem, for goodness sakes? It's out here, wasn't it? Was this what they were asking? And this is equal to 63 over 65, with the help of formulas. Shane,
Yeah.
I know we're all tired. I'm looking at the clock, because I had a few things to announce. But is there something else there we should work out?
There's a few other
There's
things.
plenty of them, I think.
Uh-huh.
Okay, find one that you think looks difficult.
Do you want one to the scale of what we just did?
Whoa. Hang on. Tell me what that looks like. If I see it's gonna be too lengthy, we may not tonight.
It's sine of inverse sine negative 4 over 5 minus inverse tangent 3 over 4.
Minus inverse tangent,
Mm-hmm.
3 over 4.
Mm-hmm.
Oh, yes. Much like this one. Maybe I'll just leave that for the extra credit. The 2 points I'm talking about. Gee. 2 points. Maybe 1 point? You said 1 point, right?
4.
No, I thought you said 1.
I said 10.
Oh, you said 10.
I
Oh,
think we should put it to a vote.
yeah. I'll see you doing something. Okay. No, so guys, I'm not gonna do that one. I'm not gonna touch it. That
Okay.
might be it. I haven't decided yet for your 2 points. I'll let you know. Yes.
It says establish.
Now, I'm gonna go down to that one,
That
yes.
one?
Now, it's that, not this one.
No.
Okay, now, here we go. Let's maybe close this down. Chapter 6 is done. Do I see you guys tomorrow?
No.
Friday?
No.
Weekend?
almost wish you did.
Weekend? Maybe. That'd be so cute, just have a little party. Yeah, do math. Okay, Shane, what's the one that says establish, and I may stop with that?
It says establish pi over 2 minus theta is equal to, establish cosine pi over 2.
Okay, read that to me again.
Cosine pi over 2
Cosine 5 over 2
minus theta
minus theta.
is equal to sine theta.
Oh my gosh, we've already done this one.
Yeah.
We did this one. Yeah, didn't I?
Yeah.
We have the formula.
We used the formula, cosine A minus B,
Oh,
and
okay.
it worked out. Now, was there another establish? We did this, which is gonna help me out. We've already done this one.
No.
No other one? That's just it.
Is it just like establish means like the rule, like show?
There you go, you gotta show the two sides are the same. Those are the, I see what it is.
We did it.
Alexander,
Approved, right?
yeah, it did not say this. It didn't say solve, establish, like a little proof, exactly.
Okay.
Prove it is equal to,
Okay.
and we did that earlier. Shane, what else is on that handout?
On this side, we have tangent of 7 pi over 12, or we have the other side of the sheet.
Okay, hang on now, hang on. We got the harder one out of the way.
We did
Yes. Now, sine of 7 pi over 12?
Tangent. of
Tangent,
7 pi.
gotcha,
We already did sine of 7 pi over 12.
gotcha, gotta do this. Get by to chapter 6 here. Now, you've never seen 7 pi over 12. Alex, tell the class, how might I rewrite 7 pi over 12 and get some help here?
4 pi over 12.
4 pi over 12, and what, 3 pi?
Yeah.
This class is something else. That's exactly right. Now, Ignacio, with his help, this says tan A plus B. I don't think I gave you a tan A plus B formula. Is there one out there in your textbook? Yes. I'm not gonna hold you responsible for it, you have enough formulas as it is. Can you tell me how you could find the answer without turning to the book and looking at another formula based on what we've done in class.
Sine of A plus B over cosine
Thank
A
you.
plus B,
Sine A plus B over
cosine A.
cosine A plus B, gotta be equivalent to tan. We've done it. Guys, this is one of the best classes. Mr. Park, Ms. Susan, you guys have been with me a long time. This has been one of the best classes ever with the responses I'm getting from students. Guys, this is true. Sine over cosine is tangent. Now, Ignacio, remind the class what the sine A plus B formula is. I'll put it right here.
It would be sine A cos B
Hang on now. Sine A cosine B,
plus cosine A sine
sine A sine B. I'll be using that. Remind the class what the cosine A plus B formula was down here.
cos A cosine B
Okay.
minus sine A sine B.
Guys, I gotta apply those and we'll finally have this finished. And have a wonderful night here. Okay. Whew. Alex gave me this, guys. And by the way, this would reduce down to, look at this, pi over what, 3? Plus pi over what? 4. Does that take me right back to the unit circle? So all this says with Nasiru's help, this says what? Sine of pi over 3, right next to it cosine pi over 4, I just put a little string, plus cosine pi over 3, put that in here, sine pi over 4. Guys, we continue with this sine pi over 3, unit circle, guys, someone help me, what's the sine of 60 degrees?
Root 3 over 2.
Root 3 over 2. Cosine of pi over 4, I know that one's radical 2 over 2. Cosine of 60 degrees, cosine pi over 3 is what, 1/2? And this is a radical 2 over 2, directly from the unit circle. Therefore, the top part that he gave me is radical 6 plus radical 2, all over what? 4. Let me block that off, that's the numerator. What a nice problem to just close the class down with. Now, denominator. That says cosine, what was it? Cosine pi over 3. Cosine pi over 4. Minus sine pi over 3. Sine pi over 4. You guys have worked hard tonight. Guys, cosine of 60, help me out.
1/2.
1/2. There we go again. This is radical 2 over 2. Minus, this is radical 3 over 2. All unit circle. Radical 2 over 2. All together, guys, it's radical 2 minus radical 6, I think it is.
Yes.
All over 4. Yes or no? So I've got this over this, I think, to get tangent. Sine over cosine. We do the work up here. Got this. What a beautiful problem. Over this. I hope I don't have anything wrong there, Richard. You guys agree? I know these are going to cancel. So we have this. Now, can someone tell me, and Mr. Parker, I'm here to check this. I cannot leave it like that. Can someone tell me those radicals in the denominator have to go? Can someone tell me what would I multiply, they call it rationalizing. What would I multiply by to clear those radicals out of that denominator?
Radical 2 minus radical 6.
Alexander, tell me again.
Radical 2 minus.
Oh, we're getting close. Radical 2, how much?
Minus radical
Oh, plus.
plus.
Plus. Look at this. It's called a conjugate. Change the sign in between. Now, let's see why radical 2 plus radical 6 in the red was chosen. Because this now takes the form of, and guys, look at this, in my denominator, this looks like an A subtract B to me, times in the red, A plus B, which is A squared minus B squared. Is that true? So that denominator should be the A squared, which is radical 2 squared, subtract B, radical 6 squared. Guys, is that 2 subtract 6? Is that negative 4? Okay, so the bottom part, denominator, is merely, believe it or not, negative 4. Yes or no? Top is not as nice, but I bet some of my students could tell me what you're going to get. When you multiply those two together, guys, this times this is radical 12, isn't it? Like expanding this thing out. I see these two are what, radical 4 or 2? So when you mess this up, we're near the end of class here. These two, is that 6? And I got one more I think I gotta worry about. What am I leaving out? Where's the other one? I think there's one more term here. What am I looking at? Do I have a radical 12?
Yeah.
Is that true?
Yeah.
I'm sort of using that FOIL system. Is it a radical 12? Wow, Mr. Park, we're gonna close down this. Let me step back, guys, and check it myself before radical 2, radical. Whoa, is that radical 36?
Which is supposed to say, yeah, we made that, we did switch it on.
And we call that what, 6? Oh, we call that 6.
Mhm.
So you guys agree?
Yeah.
I'm gonna check it here. Answer, I know, you know, this is this. I think. I'm gonna get a strange answer. Combining like terms, do I have 4 of those, we think? I'm getting scared of this problem. Plus 8, all over what? Negative 4, yes or no? Reduce everything down by 4, I could call it radical 3 plus what, 2?
Yeah.
Over like a negative 1. Better yet, merely this. Mr. Park. Classes, yes, we're going in. Mr. Parks, please. Here we go. We're trying to find the original problem. Where was it? What was I doing? Was it down here? Was all this business here?
I guess.
Mr. Park, please give me the tan of 7 pi over 12 directly.
Negative 2 minus root 3.
Negative 2, how much?
Minus root 3.
Negative 2 minus
Root 3.
root 3.
Yeah, root 3.
Like this.
Yeah.
Where's my answer? Did we get this?
Yeah.
You said the calculator shows where on earth did I place it for the calculator here? Did you say we got the same thing?
Yeah.
They agree. What a class. What a class. Okay, guys, I'll see you on Monday. Get you ready for that big knockout exam.